Okay, now we will talk about the algorithm of Sqoop export. So when it comes to Sqoop export, your Hadoop cluster will be the source, and let's say you have the EMP table in HDFS. Okay, what will happen? Let's say the table size is 10 GB or 10 GB, and you have a 10 node cluster. Okay, you have 10 node cluster. So on average, and the block size is 128 MB. So on average, let's assume that replication factor is just 1 for simplicity purpose, just to understand the algorithm. On average, each node will have 8 splits, because 10 GB with 128 MB, you will end up with 80 blocks, and these 80 blocks will be stored in all the node, will be scattered on all across all the nodes in the cluster. On average, each node will get 8 blocks. Okay. So when you try to run a Sqoop export, okay, and target will be the database, and you are trying to load data into EMP table. For this, you have to pre-create the table. Table needs to be pre-created, otherwise it will fail. Okay, and then you have the Sqoop client from which export will be run. So it will generate the MapReduce code, and depending upon the number of mappers, the number of mappers in the context of Sqoop export will just control how many mappers that can run simultaneously for that job. So in this case, yeah, our block size is 128 MB, there are 80 blocks, and the split size is by default equal to block size. So 80 mappers will be created, have to be created to process the data. But as you are specifying number of mappers as 4, even though the job requires 80 mappers, only 4 mappers will be copying the data from 4 different blocks at a given time. Once those mappers are getting completed, other mappers will kick off, and at the end of the job, there will be 80 mappers which will be processing the data. But as it is controlled by num mappers, only 4 mappers will run at any given point in time. So it uses typical MapReduce algorithm to process data from the blocks using the splits, and based upon that, it will create the mappers, and those mappers will read the data from HDFS as any normal MapReduce job, and it will try to write the data into the target table. And depending upon the target table, you have to make certain changes in the target table so that you get the desired parallelism. For example, if this is Oracle database, what will happen is there is something called initRANS, and by default it is 1 at table level and 2 at index level. So even if you use the 10 as number of mappers, there should be 10 connections that will be connected to the database, which will be loading the data. Okay, but because initRANS is set to 1, only one transaction will get the control on the table, on many blocks of the table, and it will only try to write the data, and others will be waiting on this. So features like initRANS can make it serialized. Even though you are using 10 parallel threads, there can be some database features which can make it serialized. To avoid that, if it is Oracle, you can increase the initRANS to 10, which is equal to the number of mappers, and then data will be loaded in parallel without any issues. You will get 10x performance if you just increase init-trans to 10. I'm not going into too many details about init-trans, but at this time you just understand that you need to be aware of database features such as init-trans if it in the context of Oracle, which can actually serialize the process even though you are using 10 mappers. Unless you understand those things, you will not be able to get the desired parallelism. So in this case, to mitigate the issue, you have to increase the init-trans of the Oracle database to 10, and then you can copy the data in parallel. So that is about Sqoop export. So we have covered Sqoop import as well as Sqoop export. So now we will go to the next topic. So Sqoop export is to get data out of Hadoop-based systems into conventional databases or NoSQL data stores. It uses map or map reduce framework. At this time, it only understands the HDFS directories, not Hive tables. It also splits data, but uses HDFS splittable logic. So now to come back to the Chintan's concern, what about delta? So this third statement is very important. At this time, it only understands HDFS directories, not the Hive table. So it, unlike the Sqoop import, where it will actually query the table based upon certain clauses which are defined as part of the Sqoop import, it can actually, you can filter out already copied data using the features what I have explained earlier. Because it generates a select query from the table, it can apply these square conditions and you can filter out the data that is already copied. But when it comes to export, it will not run Hive queries. It will use the Hive tables as HDFS files, and it will apply. It will just try to copy the data. So there is no way for Sqoop export to do the loads for delta directly. So what you need to do is you have to club Hive and Sqoop together to get the delta. So it's a two-step process. If you want to load delta using Sqoop export into a target database, then it's a two-step process. First, you have to create a Hive table using the query to capture the delta. And as you are aware, Hive table is nothing but a HDFS directory. So let me go here and launch Hive. And show databases, use cards, show tables. So if you do describe formatted large deck, you can see the location of the table. So Hive table is nothing but a HDFS directory. So when you actually create a state table for delta, delta table, you can use that directory now to do the Sqoop export. So Sqoop export for delta is a two-step process. First, you need to create a Hive table, which will actually get the delta from the underlying original Hive table and store into a new directory. And from there, you can do the Sqoop export. And other way is by using partitions. Which scenario Sqoop export is needed? So let me explain you a little bit on that. It's a very good question. So let me go to some other document. So I have, I think I have spoken about this picture earlier. So in most of the enterprises, Hive is primarily used for ETL. And for reporting layer, they are using traditional BI tools like Cognos, Business Objects, MicroStrategy, or any other traditional BI tool for reporting purposes. Okay, so there are many advantages of using traditional BI tools because they're proven. They have features like security, and they have features like ad hoc queries, scheduled ad hoc reports, scheduled reports, and many other features. And they support many formats like PDF, formats like PDF. So and already almost all the enterprises have unlimited license for these tools. So they can leverage those features for reporting purposes, and they can use Hive for ETL purposes. So once the ETL is done using Hive or Hadoop ecosystem, if we can port data back to the reporting layer, you can leverage your BI tools to actually to leverage the existing BI tools to do the reporting. So this is the architecture how you can use the Hadoop ecosystem for ETL. You will have ODS and enterprise data warehouse, which will have the actual data in Hadoop, and also you can use the Hadoop cluster for ETL. But for reporting, you need to have a traditional RDBMS so that traditional BI tools can do the reporting without many issues. So now Sqoop export will come into picture to get the data from already processed data in Hadoop into this reporting layer, and then a reporting layer can do the reporting. What do you mean by, so as I mentioned to you, to do the ETL. Even in this picture, you have ODS, so there will be a separate database for operational data store. There will be separate set of servers for your ETL for tools like Informatica or Ab Initio or Data Stage, and they are the typical ETL tools. So you need to have separate servers for ETL layer, and then you will have separate database for data warehouse. So it could ODS could be an Oracle, and this data integration layer will be running products like Informatica, and the data warehouse can be something like Teradata or Netezza or any other data warehouse appliances. So if you use the traditional architecture, you need to support these three kinds of stuff, and this can be pretty heavy. The data warehouse can be pretty heavy, and but you can directly use the reporting layer to connect to the data warehouse and generate reports out of it. But in this case, you have ETL, ODS, and EDW on the same Hadoop cluster, and your reporting database will be very light. You can use any simple database to do the reporting, and so you are actually reducing the layers. You have only two now. Earlier you have three, and they are pretty, and they can be significantly different, and they are also not scalable. Whereas this one, you can get the desired scalability for most of the use cases, and now you have consolidated your infrastructure by having a very simple reporting database and your Hadoop cluster to do most of the processing. And reporting database will be only used to report to generate the reports for your reporting layer. Does that make sense? Okay, so that is about Sqoop export. So Sqoop considerations, generic need to customize to leverage strength of underlying source or target conventional databases, which I have explained earlier. For example, in Oracle, if you have to get desired parallelism, either you have to reduce the commit rate. I think there is a parameter for that. If that is not there, you have to increase the init trans depending upon the number of threads you are using to load the data into the target database. Determining the number of mappers and outliers. So you need to make sure that you use the number of mappers. When it comes to Sqoop import, it is very important to determine the number of mappers, because if you are copying a very large table and if you specify 20 as mappers, then it can backfire and it can take all the resources on the database, and it can impact the performance of the core applications that are running on the database. It could be the case for both imports and exports. So the degree of parallelism, even though Hadoop can scale with respect to the parallelism, the database might not be able to support those many number of connections while copying huge sets of data. So you have to be very careful to determine the number of mappers, and also you have to keep outliers in mind to get the desired parallelism. Working with binary data, you have to be familiar with how to deal with binary data. It is a little bit complicated, but I'm not going into details at this time. You rarely deal with binary data. So it will not be able to read hcatalog, especially for exports. So you have to use a combination of Hive and Sqoop to get the delta. And compression, you need to use the splittable compression, otherwise you will run into issues. Okay, I haven't covered compression, so don't worry too much about this. But if you are using compression, at that time you have to be aware of splittable compression and non-splittable compression, the difference between splittable and non-splittable compression. And if you are using Sqoop, when you generate Hive tables for Sqoop export, it is better to use splittable compression than non-splittable compression. Don't worry too much about this at this time, because DBS will not be, or administrators will not be typically running jobs at this level. It will be responsible of the application development teams. But for DBS need to be aware of certain features, because they might have to run some ad hoc exports and imports, and also they need to support the scripts provided by developers. Okay, now we will see the setting of Sqoop and Sqoop 2 using Cloudera Manager. Okay, we'll take break of 10 minutes. So now we are talking about setting up Sqoop and Sqoop 2 using Cloudera Manager. I hope you guys can hear me. So it's pretty straightforward. You click on Add a Service. And as I mentioned to you earlier, the Sqoop 1 is just a client-only tool. So it is very straightforward. You click on Sqoop on client and connect. And you have to specify the gateways. The only thing that is there is gateways, because it's a client-only tool. So you just have to configure your node wherever you want to run as a gateway. So I'm selecting everything as a gateway for Sqoop, and click on OK, and click on Continue. You need not even restart the cluster. Just deploy it and run it. Okay, while it is creating, we will also set up the Sqoop 2 also. So again, click on this small square, click on Add a Service, And now if you do Sqoop tool, Sqoop is a tool designed for efficiently transferring bulk data between Hadoop and structured data stores such as relational databases. So this one is a little bit complex compared to the real one. So you have to select the dependencies for Sqoop 2. Click on continue. Now you have to configure the Sqoop 2 server. So let us configure on one of the masters. Let us do it on 6. So 1 to 6 we are designated them as masters. Sorry, 2 to 6 we are designated as masters. 0 and 1 will be gateways. So I will when we actually start setting up, there were issues with 1 and 8. We haven't seen what the issues are, and we haven't added those hosts yet. But on Sunday we will take care of that. So I'm using 6 as the Sqoop server, and click on OK, and you can click on continue, and then you can hit on continue. And it requires it requires the database for the repository. By default, all these tools use Delby, which is an in-memory database. When we actually set up Hive, it asked us about changing the password when setting up itself. But tools like Sqoop 2, which is still in beta, and also Woozy, it uses Delby by default. And if you want to change it to MySQL or some other traditional database, then it is a little bit more complicated. I will explain that when we talk about Woozy. But for now, we will just use defaults. Click on finish. So now both Sqoop 1 and Sqoop 2 are available. You can click on Sqoop 2 and you can go to configuration, and you can see the database. Okay, so it is using file system meta, so it does not require the database. So as it requires the file system for Metastore, I think we are good. There is no need of changing the underlying database. Only with Woozy we have to do that. Okay. So the Sqoop 2 interface will look like this. Let me exit. So the command is Sqoop 2. You can hit enter. And the command line interface for Sqoop 2 will look like this. So we are on the gateway node, which is 00. So it will act as a client. Let me see if I have to add gateway. Add all instances. No, no need of doing anything here. And it will use the interface like this, and you have to create the connections and all those things. You can do /h, and it will give you several options where you can create the connectors, jobs, and all those things, and you can submit the jobs using this interface. It is still in beta, and I try to come up with an exercise, but I was running into issues, so I dropped in between. But eventually, it will be reliable, and they will work on it. Because this addresses so many issues that are available, that are there in Sqoop. So it will be the standard very soon. So you can start from here, and then you once they provide reliable documentation, you can follow the documentation. And the only difference is about creating the connectors and using those connectors as part of your jobs, rather than specifying the JDBC URL, username, and password. For each Sqoop command, you can leverage the connectors that are already created. That's the only difference. Apart from that, the way import and export, the algorithm to read the data, it will be same. But there are minor differences, like Sqoop 2 uses map and reduce to get the data from source into sink, whereas Sqoop uses only map-only jobs. But for commands, that won't make any difference. It is implemented internally. But the logic to split the data and all those things remains same. Okay, now I'm going to Sqoop, and let me see if I have any slides. Yeah. So before doing the demo, we need to talk about the parameter files. Parameter files are not that important. Sqoop 2 is still in beta. We have Sqoop.properties and Sqoop bootstrap properties under etc Sqoop conf. So if you go here and if you do /etc/Sqoop 2/conf, you can see the Sqoop.properties and Sqoop bootstrap.properties. So these are the parameter files. They are not XML files. They look like this. Again, you can explore these things once you decided to start using Sqoop 2. Okay. So it will give you more control over the execution of the Sqoop jobs. Okay, with Sqoop there are no properties files. You can actually check that. Cool. So this is for Sqoop. There is a Sqoop site.xml, but you don't see anything over there. The only thing is if you want to override certain parameters, which are there in HDFS site.xml or mapped site.xml or iron-site.xml, the core XML files for the core components. If you want to override certain parameters, you can add those parameters to here, like split size, etc. And you can override further Sqoop jobs. For that purpose, they have provided the Sqoop site.xml file. Okay, typically you don't modify Sqoop site.xml for most of the scenarios. And Sqoop log files. I'm not sure about Sqoop 2, but Sqoop does not store log files anywhere. When you run the Sqoop job, you have to redirect the output of the command using Linux redirect process. So I will show you that as part of the demo. But like Hive, where we have the logs under temp and the OS user, which is used to run the Hive commands, and the logs will be created over there. Whereas for Sqoop, there is no such location. It will not copy the logs to the temp. It will be output will be emitted wherever you run the Sqoop command, and if you want to preserve that output, you have to redirect the output using the Linux redirect process. And for the map tasks that are used to run the export or import process, you have to go to the map reduce job logs using your resource manager UI. So I will show you both the approaches as part of the demo. Okay, now demo, we have to start with installing MySQL connector. So in this case, I have the Sqoop client on all the data on all the Sqoop client, which is a gateway on all the nodes in the cluster. So I should be able to run the Sqoop command from anywhere, any node in the cluster. Okay, because everything is a client. But to connect to the database, we need to have connectors. And as I'm using the gateway node, and I have MySQL database. I'm going to use the password, and I have the databases in this. So I'm running the Sqoop here itself. So I just have to identify the MySQL connector, and I have to copy the connector there to Sqoop lib. And the location for Sqoop lib is cd val lib Sqoop. So here I have to copy the MySQL connector. Okay. So first let me find out where my MySQL connector is. So here is the location of the MySQL connector. If you do not have this, you have to install that. So I will create a document to take care of all the steps. So for now, let me show you the command. So you have to, wherever you want to set up the MySQL database, you have to create database over there. And then on whatever host you want to create the MySQL, on whatever host you want to run the Sqoop commands, you have to install MySQL connector. MySQL connector is nothing but a JDBC jar file using which you can connect to the database from any node. So in this case, we have MySQL database on 0. Where is it? So this is the host, and the IP10.00.15 is the host, which have the MySQL database as well. So in this case, if I want to run Sqoop command from any other node than this, as there is no database on those nodes, you have to have at least a connector. Once you have the connector, you can run the Sqoop command on the other node also, and you can load the data into or from the MySQL database. Okay. For demonstration purpose, let me run the Sqoop command from other node than the gateway node. In this case, let me come out of this. Now I am connecting to 501. Okay. I have to have MySQL connector. So now it is installing the MySQL connector. Now it is installed. Now if you run sudo find name MySQL star.jar, you can find this. But if you run MySQL -u root -p, as there is no MySQL database, this command will fail. So now using this jar file, we can connect to any MySQL database on any other host which we have access to from this host, and we can do whatever we want as a client. So in this case, Sqoop is the client which is trying to read or write data from MySQL database, which is on other node, which is IP10.00.15. Okay. Now let me create a soft link for this file under val lib Sqoop. Okay, how to use sudo command. Okay, it is created now. Now, once it is done, what you have to do is you have to log into the MySQL database, and you have to create a MySQL database is on .500. So I am connecting to the host where we have the MySQL database, and I am logging in as root 20 and so databases. So there is no, there is a database called demo, use demo, show tables. So there is a table called cards in there. So it is empty. So let me describe the table. So there are 3 columns. So first, as we already have the data in HDFS, first let us run the export so that we can copy the data to the MySQL database. So first let us look at where we have the data, users, HD users, and the cards, I think data. cards. Let me check. Okay. Let me check on the 15th. Exit. Hive. Store databases. Use cards. Store tables. And we have a single deck. We will use this one to copy data from HDFS into MySQL database using Sqoop export. So let me modify the Sqoop export command. I will provide the script by tomorrow in the scripts directory in the shared drive. Okay, so this is the command which you need to use. Okay, so you have to give the IP address of our database, which is IP 10.0.0.15, and the database name is demo. And who is the user? I think demo. Yeah, demo Hadoop 20, and let me do MySQL minus u demo minus p. Hadoop 20 is the password now. I know. I think it's demo underscore user. Yeah. So show tables, use demo, show tables. So table name is cards, and demo underscore user is the username. So table name is cards, and the export directory in HDFS is user hive warehouse cards.db. And then exit. Hadoop FSLS user hive warehouse cards.db single deck. So we are trying to copy from the single deck. And then we have to tell how the data is organized in the file. So for that we have to specify input fields terminated by. In our case, we are using the pipe, as you are aware of the data set, and then lines are terminated by new line character. And I'm using two mappers to process the data. In this case, it might use only one mapper because the data set is so small and we have only one block for the single deck. First, let me run this. If it is successful, then I will try to run on the large deck as well. Okay, we are trying to run it on 16. So I'm running it on 16. What? Okay, I know the problem. The problem is with this one. This is a special double quote rather than regular double quote. Okay. So you have to be careful if you use DOS editors, even with Mac, some characters can convert into special characters and it can cause issues. So now the job is running. Input path does not exist. What? Let me see. So Hadoop SSLS user hive warehouse cost.db. What? Okay, something is wrong with this. So let me see what is the issue. HDFS instances. Gateway as well. Okay, there is some issue with 16. I will figure out later. Okay, 16 is 1. Is it 1? Yeah, that is the problem. I have to use the 2. Yeah, 16 we had issues when we actually set up the cluster. So that's why we ran into issue. Now let me install the connector on 17. So the reason why it failed on 16 is the installation failed on day 1 or day 2 when we try to set up CD cloud. When we try to install the software on all the hosts in the cluster, it failed on 1 and 8. So 1 is not actually official in the cluster. So that's why it ran into issue. So instead of 1, I am using 2 now. So now let me sudo find name MySQL store.jar. Okay, now we have that. Now sudo ln-s. I'm creating the soft link for the jar file under var lib Sqoop MySQL connector java.jar. Okay, it is created. Now I will run the MapReduce Sqoop job. This is the command. It's a Linux concept. So we instead of copying the file, I just created a soft link so that you can access the file from 2 different locations without copying the data. So it's a Linux concept. You can actually explore, and if you are targeting for admin jobs, it is very important to understand all these Linux concepts like soft links, etc. So now the data is copied. So let us validate on the database in MySQL database. So now I am going into the host where we have the MySQL database, and I am connecting as a demo user. Password is Hadoop 20, and use cars. So use demo and show tables. And earlier we have validated that the table is empty, and now you can see that there are 52 records. Okay. So, and now if you try to decipher the output that is generated, most part of the output is from the MapReduce framework itself. It has the counters information and also the progress information from the MapReduce framework. But there are certain differences like this one. Okay, so using this query, it will query the metadata of the table, and it will create a jar file, and where it will create a POJO class, which defines the structure of the table. And by default, it will create a directory called Java files wherever you are trying to run the job. And if you go to the Java files and check the file, you will run ls command to look at the details under the directory. You will find a Java file, a text file with Java extension, with the table name as the name of the file and the extension as Java. And if you look into that, it is nothing but a plain old Java object with getter and setter methods for each of the columns in the table. So we have 3 columns in the table: color, sweet, and tip. So it uses this information actually to read the data in structured manner, either for copying data into Hadoop or copying data out of Hadoop into relational databases. Okay, and that is about Sqoop export. As there is only one block, it might have created only one mapper. It says number of splits 2. Let us validate the logs. You can go here. And you can connect to the resource manager and start looking at the details. So it has launched 2 mappers because we have specified number of reducers as 2. So let us see what each mapper have done. You can click on map tasks, and you can click on each of the mappers, and you can click on counters. And this one actually read 26 records. So actually data is splitted. Oh, let me see. I thought it will not be splitted. Let me see. Hadoop access minus ls user hive warehouse parts.db small deck. Or single deck. Okay, there is only one file, but still the data is splitted. Okay, so it is using actually combined file input format internally. I will look into these details later, and I will explain. I will try to come up with the explanation why it is using two mappers and data is equally distributed. I thought it will not be the case. Now, if you try to copy data from a large deck, you can run the same command with the different location in the HDFS, and you can give more number of mappers. Let's say 4. Set minus OBI. So I'm giving the large deck. I can hit enter. Now it is using 4 splits. So my understanding was incorrect. So I will revisit that later. But now you can actually monitor by clicking on the link. As it has 2 GB of data, it will take a little while. We will not wait until then. We will stop in the middle itself. And if you see, it is only using 4 mappers. So the number of threads are whatever you have given under number of mappers, it will use only those number of threads for the export. So my understanding was incorrect. I thought it will use the number of mappers based upon the split size, or they might have changed functionality recently in the latest version. Anyway, I will fix this, and I will create a different video and upload into YouTube based upon this, so that you have the correct information for your reference in future. Okay, that is about export, and it will take a long time to complete because the database might not be able to cope up with the amount of load. Yeah, it is doing good job actually. No, actually it is a little bit slow. So we have 160 million records, more than 160 million records to process. It will take an enormous amount of time to do that. So I'm killing it in the middle itself. Okay. So you can actually run mapped job list to see the running job, and then you give mapped job kill to kill the job. Okay, now the export is done, and now I will run the import. So when it comes to import, the command will look like this. So in this case, the host name is IP10.0.0.15, and database is demo. And username is demo user, password is Hadoop 20, and table name is cars, and number of mappers I will use the 10. Let me use that 4. Fields terminated by pipe and lines terminated by new line character. These two are not required. Let me see. Yeah. So these two are for only export. For import, you have to use fields terminated by and lines terminated by, because in databases you don't have the concept of delimiters. The delimiters are managed by database in its proprietary format. So in this case, only to read the data, only to write data into HDFS, we have to give the delimiters. If you do not give the default if you do not give these delimiters, it might use custom values, and I'm not 100% sure. Sorry, it will use the default delimiters for both fields and line. For line, it is new line characters as default, but for field, I think it is null character or something. I don't remember on top of my head. But to satisfy the table structure of the underlying table, you have to give whatever delimiter you are using at the table level. And we are actually using pipe, or we want to use pipe in Hive, sorry, in HDFS. So I am giving pipe as a delimiter for my fields, and then I have to give the Hive table. In this case, let me give large deck and Hive import. There is no need of check column. I don't want to do incremental, and I don't want to do last value, but I want to use split by. Very good. Okay. And actually, instead of Hive, I will just use the target directory. Where is the target directory? Yeah, let me use this one directly instead of. So I will use IP 10.0.0.15 and demo user and Hadoop 20 the password. Cards is the database and HD user cards as the directory. Sqoop cards as the target directory. And I have to use fields terminated by, not the input fields terminated by, and lines terminated by. And I can give number of mappers as 4, and I have to use split by. I would like to split by pip or suite. Okay, now I can run this command. Setting your password on the command line is insecure. Okay, that is fine, but still it should run. Why it failed? Error passing argument for input. Unrecognized argument. What is unrecognized argument? Table cards. Is there any special character somewhere? Just give me a minute. I will try to troubleshoot. Otherwise, I will. Okay. Yeah, it is here. I know. There is a space in the end that is causing the issue. Now let me run this. Now it is running. So now you can monitor the job. So it is using 4 mappers, and we have specified in number of mappers. It is already done. Yeah. So there were 821,000 records, and they are copied to HDFS. Now, if you want, you can actually validate by looking into this target location. Hadoop FS -ls, and you will see 4 files there. And if you see, it's a classical case of skew. One of the mapper have processed double the data than the other 2 because the range logic which is computed on the basis of weight which is given in the split by clause is missing one of the values and it is not falling in the range properly. So to fix this issue, you need to come up with a solution where you create a view like this. Sorry, let me show you what you have to do. So tables, describe cards. So what you can do is okay, in Oracle I can find out the solution. In MySQL it will be little bit tough. So I will not be doing that right now. you can actually, if you are using Oracle, you can compute hash value on the field, and you can generate a unique 4 different numbers for each type of suite, and then you can create a view on top of that, as I have explained earlier. In this case, I am not 100% sure about the MySQL how to generate the hash or numeric value with the data we have. So I'm not actually demoing right now. But there is one solution where you can provide, you can come up with manual parallel processing instead of defining number of mappers as 4 in the Sqoop command. What you can do is you can specify where clause. So you can go to the reference guide and you can specify like this. Okay, so where weight equal to ready. So what you can do is you can give like this 0, 1, and number of mappers should be 1. And now you can run this command. So for each value in suite, you can run a different Sqoop export command with only one thread by customizing number of mappers to 1. That way you can achieve the desired parallelism, because that one will make sure that you are using 4 threads to copy the data. So this is one of the workarounds for that Sqoop problem. And you can actually run using NoHop in parallel. For example, what you can do is, we are almost done with the Sqoop, and also we are almost done with today's session. So just bear with me. So you can actually run like this. Art, diamond, club, paid. Why it is taking so much? Yeah, so it is all done. Now if you do Hadoop SS minus ls users hd user, sorry, and if you give Sqoop cars 0 star, if you see now the data is splitted across all the 4 directories, which is more even. So this is how you can work around the problems. You have to think through each of the problem and you have to come up with a solution. And one last thing which I need to explain is how to log this information, because you might have to log this information and send alerts out of it. With Sqoop tool, I think you can integrate with Cloudera and Cloudera Manager and get the alerts. But with the Sqoop one, you have to redirect the logging information to a log file, and then you have to create a shell script which can actually send emails in case of any issues. So the way it will work is you have to redirect the standard error into a log file like this, I think. Yeah, sqoop.log. Okay, so there is an issue with the command. Let me take care of the one which is working. So let me do this. So two stands for standard error, and this is a typical syntax to redirect. So if you want to capture the Sqoop log is emitted out as standard error. So you have to redirect the standard error to a log file. I think there is some issue with redirection. Let me check the syntax. Redirecting standard error. To log file. Just 2 greater than, yeah. Yeah, now it is working. So now if I see, yeah, now if I look at sqoop01.log, directory already exists. So it is a valid error. So this is how you can redirect the output of the Sqoop command, and then you can actually pass for the errors and you can send an email. Okay, because as this is failed even before the MapReduce job is created, you cannot capture this error from the MapReduce logs. So if the MapReduce job is initiated, you can actually, by monitoring the MapReduce logs, you can send the alerts using Cloudera Manager even with Sqoop 1. But if the MapReduce job is not initiated, then to capture the errors and to alert the support team, you have to integrate that with within a shell script to send an email by grabbing for the errors in the logs. That is how you need to implement. So that is it about Sqoop. Let me know if you have any questions. Otherwise, we will stop for today, and we will review more